This 1940s DoAll V-36 bandsaw shears through hardened steel like butter, its blade unwavering after decades of relentless pounding. Modern bandsaws, fabricated from thin, stamped steel sheets spot-welded into frames, twist and buckle under basic tension, sending cuts veering wildly offline. What brute force secret allowed the DoAll to conquer metal, while today's machines surrender to the slightest strain? It was 1933, the pit of the Great Depression, when American factories teetered on collapse. Bread lines snaked through cities, banks crumbled, and industries bled jobs by the million. Steel mills idled, auto plants shuttered, and the nation clawed for any edge to survive. Leighton A. Wilkie, a sharp-eyed inventor from Illinois, saw the chaos firsthand. Machinists wasted hours swapping dull hacksaw blades or wrestling with clunky horizontal saws that mangled expensive stock. Vertical bandsaws existed, but they were finicky beasts, frames that flexed like willow branches, blades that snapped mid-cut, devouring time and profits factories couldn't afford to lose. Wilkie's DoAll changed that overnight. Patent in hand, he unleashed a machine that sliced intricate shapes from tough alloys without pause, feeding the hungry maw of rearming industry. By the late 1930s, as storm clouds of war gathered over Europe, orders flooded in. America faced do or die. Equip an arsenal or watch the world burn. Failure meant not just bankruptcy but surrender. Submarine hulls unbuilt, aircraft frames uncut, tank treads delayed. The DoAll didn't flinch. It became the backbone of victory production, churning out precision parts when every minute spelled survival. No room for excuses, no tolerance for breakdowns. These saws had to endure hellish shifts, 24 hours a day, or the free world folded. Now the engineering that made it immortal, the true secret sauce, lay in its colossal, single-piece cast-iron C-frame. Forget the flimsy fabrications of today. This was poured as one unbroken monolith in a foundry furnace, roaring at 2,800 degrees Fahrenheit. Weighing over 2,000 pounds, the frame's sheer mass, thick walls up to 4 inches, created inertial rigidity no vibration could shake. Under blade tension cranked to 30,000 pounds per square inch. Lesser machines bowed like cheap rulers, but the DoAll's C-shape channeled forces into compression, not flex. The throat depth stretched 36 inches, allowing massive workpieces to rotate freely, while the blade path stayed laser straight through inertia alone. Heat from friction? The iron absorbed it, its thermal mass dissipating thousands of BTUs without warping. Precision guides of hardened tool steel rode on phosphor bronze bushings, self-lubricating under oil mist, holding the 0.035-inch blade to tolerances under 0.01 inches, enough to contour turbine blades or gun barrels without a whisper of deviation. But the crown jewel was the integrated flash butt welder, a stroke of genius baked into the upper arm. Snap a blade mid-job threading through a blind hole? No problem. Machinists squared the ends, clamped them into vice-like jaws, and triggered the circuit. A massive capacitor bank dumped 200 amps in a blinding flash, arcing the tips to molten white hot in milliseconds. Hydraulic rams slammed the ends together at 50 feet per second, forging a seamless weld stronger than the original bimetal strip. Chrome moly backing fused to tungsten carbide teeth in one brutal instant. Sparks flew like lightning. Ozone stung the air and the welder cooled the joint in seconds, ready for tension. This wasn't accessory gimmickry. It enabled closed-loop cuts on solid blocks, internal contours impossible on rigid blade competitors. Modern saws? They ship blades pre-welded, non-repairable, forcing full replacement every shift. Planned fragility from the start. The DoAll's overbuilt safety factor ran tenfold. Frames stress-tested to 100,000 psi before shipment. Pulleys of ductile iron balanced to 0.0001-inch runout, and variable speed motors geared for 50 to 5,000 surface feet per minute without belt slip. Every bolt was a 1.25-inch giant, torqued to 500 foot-pounds, locking the beast into granite-like stability. This wasn't engineering. It was defiance against entropy itself. The men who tamed these monsters paid in blood and bone. Picture the journeyman machinist, calloused hands, lungs black from grinding dust, in sweltering wartime shops where summer temps hit 120 degrees amid coolant spray and oil fog. 12-hour shifts, 7 days weekly, ears ringing from the ceaseless whine, pitching from bass rumble to piercing screech as blades bit armor plate. Danger lurked everywhere, a mistimed tension adjustment, and the blade whipped like a chainsaw, severing fingers or flaying arms against the flywheel guard. Weld flashes seared retinas without goggles. Hydraulic leaks crushed limbs in the ram's vice grip. Heat exhaustion dropped men mid-cut, only for foremen to drag them aside. No sick days in 1943. The bends came from stooping into the 36-inch throat, backs twisted hauling 500-pound billets onto the cast-iron table slick with swarf. Amputations were badges of honor. One veteran lost half his left hand to a wandering carbide tooth but returned next dawn, relearning the feed lever one-fingered. Noise-induced deafness was universal. Vibration palsy numbed feet after years on concrete. Yet they revered the DoAll, not like the disposable toys of now, but as a loyal brute that rewarded their grit with flawless cuts, sparing the factory from scrapped lots worth thousands. These weren't operators. They were gladiators wrestling physics, their scars etching the machine's legend deeper than any blueprint. Decades later, that V-36 still stands in workshops from Detroit to rural machine sheds, outlasting generations of owners. A 1942 model in Ohio logged 100,000 hours before a routine blade change, its frame unblemished, save for honorable dents from errant hammers. Contrast that with the 2022 John Deere tractor scandal, software bricks rendering $500,000 machines into $50,000 paperweights overnight, dealers locked out by proprietary codes chasing quarterly profits. Or the 2021 Florida condo collapse, where thin steel rebar and concrete flexed under salt corrosion, killing 98 because safety theater regs favored lightweight speed over mass. We ditched cast iron for stamped sheet metal because it's 80% cheaper to stamp and weld in Shenzhen, shipped flat-packed for just-in-time inventory. Planned obsolescence rules, frames thin as foil to shave ounces, flexing at 15,000 tiled psi tension as blades wander, forcing $200 replacements quarterly. Unions screamed for worker safety, but it was code for lighter machines easier to flip. Never mind the crooked cuts wasting steel. Profit margins trumped permanence. Shareholders demanded disposability, not durability. Today, a handful of DoAlls soldier on in museums like the National Packard Museum or active fab shops, their welders sparking anew on YouTube restorations. We've traded eternity for ephemera, buttering our bread with plastic widgets that crumble at first frost. Progress? It's the slow suicide of a civilization that forgot the weight of iron. Now, the engineering that made it immortal, the true secret sauce lay in its colossal single-piece cast-iron C-frame, poured as one unbroken monolith in foundries where furnaces belched flames at 2,800 degrees Fahrenheit, liquefying pig iron blended with just enough nickel for tensile strength exceeding 60,000 psi. This beast tipped the scales at over 2,000 pounds, its walls thickening to 4 inches in the critical throat section, harnessing raw mass as an unyielding anchor against the chaos of cutting. When machinists cranked the blade tension to 30,000 pounds per square inch via a hydraulic jack pressing against a pivoting post, flimsier frames, those modern stamped steel assemblies spot-welded like tin cans, would deform elliptically, the C-shape twisting open by millimeters under load. But the DoAll's geometry turned tension into pure compression arcs, the frame's inertia, devouring vibrations from 5,000 SFM blades gnawing quenched D2 tool steel at feeds of 100 inches per minute. Heat buildup? The iron's specific heat capacity soaked up 50,000 BTUs per hour from friction, spreading it evenly without a micron of thermal bow, unlike aluminum extrusions in today's saws that warp at half that load. Precision came from overkill at every junction. The blade guides, twin rollers of oil-hardened S7 tool steel, floated on phosphor bronze bushings lubricated by a constant gravity-fed mist, constraining a .035-inch thick .5 TPI hook-tooth blade to 0.0005-inch lateral play. Throat depth hit 36 inches, permitting a 500-pound Inconel forging to swivel full circle for compound contours. The 14-inch flywheel pulleys, cast ductile iron, dynamically balanced to 0.001-inch runout, spinning whisper smooth under 5 HP totally enclosed motors. Variable speed via a Reeves drive shifted seamlessly from 50 SFM for plastics to $5,000 for titanium, belts of woven cotton duck gripping without slip, thanks to crowned sheaves crowned to exact pulley radius. Yet the flash butt welder elevated it to sorcery. Integrated into the upper arm like a loaded cannon, it transformed catastrophe into continuity. Blade snaps mid-cut on an internal spline, ends squared on the built-in grinder, clamped in water-cooled copper jaws. Trigger pulls and a 400 microfarad capacitor bank unleashes 200 amps DC, arcing the bimetal tips, high-speed steel edge to flexible alloy back, to 5,500 degrees in a heartbeat. Hydraulic rams, powered by the same 3,000 psi circuit as tensioning, forge the molten stubs at 50 fps impact velocity, upsetting a flash butt joint denser than factory welds, upset bulge ground flat in seconds. Ozone crackled, blue smoke curled, but the joint held 40,000 psi tension without fracture, enabling closed contours on solid stock, like trepanning oilfield valves or nesting gears in one setup. No modern saw dares this. Their frames can't take the shock. Blade's proprietary loops that demand $150 swaps when teeth dull. Those who fed the DoAll's hunger bore the scars of its dominion. Journeymen in 40s arsenals, sons of farmers, mill hands turned overnight specialists, faced 12-hour marathons in shops where coolant mists hung like London fog, oil impregnating clothes into greasy armor. Summer heat fused with motor exhaust to 130 degrees, sweat blinding eyes as they muscled 300-pound billets onto the 48 by 36-inch cast table, swarf cascading like brass rain. The whine escalated from guttural hum to falsetto scream on carbide hogs, deafening without earplugs. Today's OSHA would shudder the floor. Fingers danced millimeters from whipping blades. A dull tooth snag sent .035-inch stock rocketing like shrapnel, pulping hands against the frame. Weld flashes without UV shields burned corneas to snowblind agony, sidelining men for days. Hydraulics bit back. Leaky seals crushed forearms in the ram saddle. Tourniquets improvised from shop rags. Backs broke hauling rejects. The diver's bends from 36-inch stoops knotting spines after decades. One Chicago foreman, Eddie Kowalski, lost 3 fingers to a tension release in '44, the blade coiling like a serpent before guards caught it. He machined prosthetics from scraps and resumed, logging 40,000 hours till retirement. Vibration white finger-numbed grips. Silicosis coughed up lungs from airborne grit. They cursed the brute but trusted it, unlike plastic-geared newcomers that seize on first overload. Stranding jobs. These gladiators forged victory from exhaustion, their toll the unspoken tax of endurance. Surviving the war, these V-36 marched into peacetime, absorbing post-war booms and recessions with stoic indifference. A 1941 unit in a Bridgeport shop tallied 150,000 hours by 1980, frame pitted but rigid, outpacing a dozen DeWalt Fab units that rusted into heaps. Fast forward to 2018, Boeing's 737 MAX software glitch, over-reliant code overriding sensors, doomed 346 souls because engineers chased fuel savings over mechanical redundancy, a digital house of cards collapsing under edge case inertia. Or take the 2023 Tesla Cybertruck panels, stainless exoskeleton flexing like foil under torque wrenches, recalls piling for frame wander, akin to bandsaw blades veering on thin welds. We abandoned monolithic castings for hydroformed sheet steel, stamped at 1/10 the weight, MIG-welded by robots in low-wage plants, cutting upfront costs 70%, but buckling at 20,000 psi tension as blades camber and wander 0.010 inches per foot. Ergonomics mandated lighter frames for easier shipping, but it masked planned obsolescence. Proprietary ECUs brick on firmware updates, forcing $10,000 trade-ins. Pay regs vilified cast iron sand foundries, pushing composites that shatter under chip load. Corporations like Haas prioritize EBITDA, vending $5,000 saws warranted 90 days, blades wandering on day 30, durability died to quarterly reports. We build for landfills, not legacies. Shop floors echo with ghosts of these titans today. A 1943 DoAll V-36, unearthed from a Pennsylvania scrapyard in 2019, its paint flaked to bare iron, welds scarred from thousands of repairs, fired up on fresh oil and a new blade, slicing 4140 alloy at full spec without a shim or tweak. The frame, dented from forklift collisions and hammer blows, held tension like the day it shipped, while a brand-new Jet HVBS 712 from Harbor Freight warped its first cut on mild steel, the blade cambering 0.015 inches over 12 inches due to seam-welded legs bowing under 18,000 psi. That jet joined a dumpster pile after 18 months. The DoAll, back in service, logging hours on custom knife blanks for survivalists who demand edges that endure. Walk into any active restoration bay, and you'll find them. V-36 is humming in the garages of gray-haired fabricators from Tacoma to Tulsa. One in a Michigan prototype shop, serial number 4127 from 1941, just notched its 200,000th hour restoring vintage aircraft parts for the commemorative Air Force. No microcontroller to fail, no sensors to glitch, just iron, oil, and will. Compare that to the 2020 Boeing 787 Dreamliner production halt, where titanium supply chain software optimizations idled $10 billion in fuselages because algorithms prioritized spreadsheets over stockpiles, flexing like a bandsaw frame under unexpected loads. Or the 2024 recall of Milwaukee Tool's M18 fuel sawzalls, where polymer housings shattered under reciprocating stress, lithium cells swelling from heat cycles, disposable dynamite chasing cordless hype. Why the betrayal? Bean counters in boardrooms decreed cast iron obsolete after 1970, when Japanese imports flooded markets with lightweight mechatronics. Stamped 1010 steel frames, hydroformed at 800 tons per stroke, assemble in minutes via robotic MIG guns belching flux core wire. Cost plummets from $4,500 per DoAll to $1,200 landed, but rigidity evaporates. Finite element analysis caps tension at 12,000 psi to avoid liability lawsuits from flex-induced wander. Blades track wavy lines on heat-treated stock, scrapping 20% more material. But who cares when margins hit 35%? Green mandates axed foundry sand casting, too much CO2 from coke-fired crucibles, pushing fiberglass-reinforced polyester frames that delaminate in humid shops. Fibers migrating into lungs like asbestos redux. Software layers the insult. CNC controllers demand Wi-Fi pings for updates, bricking offline like that 2021 Caterpillar D11 dozer fleet. $2 million rigs sidelined by geofencing hacks for emissions compliance. Planned fragility isn't accident, it's engineered. Change a timing belt, proprietary clips snap mandating $3,000 dealer swaps. Dull teeth, toss the loop, no welder daring the shock on thin frames. We've optimized for turnover, not triumph, vending velocity over valor. Even pro lines betray the sin. Haas TL1 CNC lathes boast aluminum beds, lightweight for agility, but thermal growth shifts tolerances 0.003 inches per 10-degree swing, idling jobs while DoAlls chug unchanging. The 2022 Foxconn plant fire in India exposed it. Polymer circuit boards on assembly robots melted into slag, halting iPhone production because fire-retardant plastics volatilize toxins faster than steel bends. Contrast a 1945 DoAll surviving Long Beach Naval Shipyard blaze. Frame scorched, but pulleys spun true post-quench. Regulations fueled the folly. OSHA's 1980s push for reducible machines under 150 pounds for solo maneuvering birthed cart-on-wheels saws that tip on uneven floors, guards that snag stock. EPA's VOC limits killed oil mist lubrication, forcing dry guides that gall blades in minutes. ISO 9000 certification chased paper trails, diverting R&D from mass to metrics. Shareholders reaped dividends, craftsmen reaped regrets. Seek out survivors, and they whisper defiance. The DoAll in the American Precision Museum, New Hampshire, a 1939 prototype, draws pilgrims who fire its welder for demos, the flash butt jointing blades flawless under magnification. Active beasts thrive in obscurity. A Texas oil field shop's 1944 model Tripans Inconel risers for deepwater rigs, outpacing $50,000 water jets that clog nozzles quarterly. California knife maker's V-36, inherited from Grandpa, contours Damascus billets daily, its inertia mocking laser cutters that pit edges with dross. YouTube channels like A Bomb 79 showcase rebuilds, 500,000 views on a tension test where cast iron laughs at 40,000 psi while a grizzly clone fractures spectacularly. These relics aren't nostalgia, they're indictments. We've bartered brute permanence for brittle convenience. Iron's thunder silenced by silicon's whimper. Progress parades as efficiency, but tallies the toll. Oceans of e-waste, skilled hands idled, nations hollowed by import dependence. The DoAll reminds us, true advancement weighs heavy, endures fire, scorns shortcuts. In forgetting that, we don't just lose machines. We forfeit mastery over our making. Iron's legacy endures because it must. Our flimsy future flexes toward fracture.